Good morning, everybody. We're involved in a couple of Bayes projects, so I think I'll try to thread through some of the knowledge that I've got about how that program's going at the moment. You might ask, what are the CAD and sort of systems that Richard was talking about earlier, and how do you get access to that data? Richard was talking about it. It is available. But now we have the practical task of explaining the steps that one needs to take in order to get access to that data. So this comes from a report that was published by the National Audit Office. It justifies why so much money is being spent on the smart meter rollout, or attempts to justify it. And these are the in-home systems which it highlights. So if you look in the sort of communications hub and smart electricity meter and smart gas meter, these are radio-connected devices. The communications hub is got a red line going off into to the right, which is going to talk to the national infrastructure. And then there are two, so the blue and the green on the bottom, local radio devices which use Zigbee radio in order to provide data into that communications hub and then back up to the national infrastructure. Now, a lot of, if you look globally at smart meter rollouts, that's where a lot of them stop, is they have the metering and billing functions and don't necessarily provide any other in-home functionality. Or if they do, it's through wired or local connections. So in the UK, there's an additional feature to the specification, which is called the Home Area Network, or the HAN, it's often called. And that's provided by the same Zigbee radio that connects the smart meter, the two smart meters at the bottom. And that provides access for an in-home display, which is in the bottom turquoise left. Again, we'll show a picture of one of these in a minute. But that's meant to read locally and also provide ability to type in a prepayment code. So if the meter is operating in prepayment mode, you can add credit to the meter through that. And you can see the dilemma if you've been cut off with electricity, you need some local way to actually top up rather than through smartphone or through the internet. And then there is another aspect, which is using similarly to the in-home display protocol, these consumer access devices. And smart appliances, which are like storage heaters, can be controlled, and an EV charging point and other kind of large load items in the home could be controlled from the national infrastructure. So this is where the distribution grid might want to say, we've got a problem with supply at the moment, we'd like to start to turn things off, or we've got an abundance of energy and we'd like to turn things on. So there's signaling that can happen through the national infrastructure. And then there are views onto the data which could be provided to the in-home apps or web portals or other kind of data consuming devices. What we at Hildebrand do is we actually make an additional device, a CAD, which has a two-way relationship. It's like a bridge device. And the idea is that it will get the high frequency data, so every 10 seconds we'll be asking the smart meter, give me your instant power, give me the profile reads of the energy that's been happening in this half hour. And that shoots up into cloud services, that information. So it bypasses the slow-moving DCC, if you're familiar with that term, data, or the national infrastructure data. So national infrastructure data is only updated either on request, which is usually daily, or on a schedule that's daily, weekly, monthly, depending on how you're being billed for your energy. But it isn't real time in the sense that you're always getting through that GPRS connection that's going out. You're not always getting the instant data. The CAD, what we call the CAD that's sat here, does provide that real-time data. In turn, you've got a lot of kind of infrastructure that sits behind that, and in order to talk to these smart meter assets, you have to be in a DCC user bucket, which is over on the far right. And you can be one of three types of companies. So one is an energy network company. So this is the distribution network. some of you might represent those, but no individual is one of these. Energy suppliers, so this is a licensed supplier. There's about 65 or 70 of those now in the UK. And then there's a role called other user. An other user is for companies that might be doing heating controls or doing academic research and want access to that smart meter data. So that's the 48 reads per day, the pricing information, etc. Although that role is still quite difficult because you have to be ISO 27001 certified, you have to go through security audits by the DCC, it's labor intensive, time intensive, etc. And what we're doing at Hildebrand is we're sort of providing as a proxy service access for companies and individuals who want to work with that national infrastructure and bypass that going through internet-based connection. Now, we have an onboarding process and we don't just do it willy-nilly. It's not something you can sort of sign up and get running in 24 hours, but it's certainly not 6 months that it takes and the £500,000 that it takes to become another user. It's significantly less. So what's our offering? So we're providing a lot of services to energy suppliers. They're at the moment innovating what their offering looks like to their consumers. How far do they go in offering energy advice? What kind of new systems can they fund and install within people's homes? Developers, I would say this is probably quite interesting for this group, at least developers and partners. So this might be software developers who want to develop apps or niche services or maybe even wide services, or analytic services. So maybe you have a forecasting method that's unique and interesting. And then partners, so this is people making metering technologies, smart heating controls, electric vehicle charging controls and things like that. And then researchers, so this might be academic or commercial research, where you need large-scale data, and I'll talk about some of our data set size in a minute. So in the flesh, this is what a CAD looks like. It's awfully like an in-home display, but there's also a Wi-Fi chip that's embedded in this device. And the Wi-Fi chip is providing that access for the data that we're querying from the meter on a real-time basis. It also means that with the Wi-Fi and the way that this is a touch screen, we can update the software to represent the electric vehicle, the solar panels, the weather conditions in real time on the in-home display. So it's not a stranded device that just talks to the smart meter, it's an internet-able device. Virtually, this can become an app, so it doesn't necessarily need to reside on a piece of hardware, but it's the bridge hardware that's really important that's inside of it. So what is CAD data? So CAD data has some interesting attributes of what infrastructure is actually in the house. So these are the serial numbers of the meters, IMPANs, MPRNs, etc. If you're operating a project, these identifiers are very important. There are real-time, or every 10 seconds, I should say, queried information about power, voltage, phase. Gas, unfortunately, is only updated every half hour, so that's not real-time as in the electricity network is. Also, on the profile data, it's 13 months of history are stored on the meter itself. So these are the 48 reads for 13 months every day. So that's an awful lot of data on the meter. It, in fact, is the only place in the national infrastructure that data is stored. So there's no, DCC does not store the data. The energy supplier may or may not store the data, depending on their systems. So it always goes back to the meter in order to query the data. Hildebrand, we actually do store the data, so that's part of the services. We're grabbing that profile data and we are storing it permanently so that it can be queried in the future. The other interesting thing is about pricing. So right now, most people don't know what their price of their energy is. They would have to refer to a bill, may not even be able to find it on the bill or interpret what it is. The meter itself, both the gas and electricity meters, publish their price now, and they also publish scheduled changes of price. If you get into time of use like Richard was talking about, then those can be very, very complex, and in fact, very hard to even calculate on a spreadsheet. So our systems are dealing with that type of application of the pricing information onto the consumption. And then there are some events that come from the smart meter as well. So messages and tamper events and all kinds of interesting things. So what we're providing also as a data service are analytic environments. So these are things like TensorFlow, NumPy, Jupyter Notebooks environments for people to come in and be able to interact with the data near the data. So you don't have to replicate all of the data because it is a lot of data. We have software developers kits, and we also kind of publish those for different languages, so you can use a language that's interesting to you to either develop an application or an analytic package. We have curated data sets, so we're automatically looking for the nearest weather station data, EPCs, OpenStreetMaps, postcode lookups, and all that stuff that's kind of tricky to do, or at least a pain to do. And then looking at things like event streams. So this is if you want to develop a model and then have data flow over that model. So that model could be something a little more sophisticated than saying, well, when I hit an arbitrary 2 kilowatts of maximum demand, I'm gonna trigger an event. It might be a model that says, well, for a duration of an average of 2 kilowatts over a half hour, then trigger the event. And it can get even more sophisticated than that. That's when you would use kind of streamed data to inform a triggered event. So at the moment, we're operating in about 27 different countries, so not just the UK. We have roughly 50,000 CT-based clamp real-time data acquisition monitors out there, and about 20,000 UK smart meter devices that are active, and that's growing rapidly. There's now over 500 billion data points in our database, so we've got a very good data set ready-made, so if people want to come in and develop models, they don't have to wait for data to be in the database. And we can also bring in AMR data, and that's very important for the non-domestic environments. On the analytics side, we're actively researching refrigeration load monitoring, so being able to disaggregate refrigeration loads. It's relatively straightforward to do. HVAC performance, so this is mixing interior temperature measurements, external temperature measurements, and disaggregating the energy load for those areas. Electric vehicle and lighting, again, reasonably straightforward to do. And then occupancy and operational hours. So there's a lot of identification of waste. If you're not there and you're not using the home, that's almost by definition waste. And then we have a lot of kind of mathematical computational elements that allow people to do things very quickly. And we've got starter apps that we provide source code for, so people can get up and running very quickly. And then as I was talking about the engine, that applies the tariff, which is more and more complicated as life goes on and tariffs get more complicated, and then can target push notifications to different cluster groups and disseminate them out through the SDKs. This is a little bit of the architecture. I think I've kind of explained everything. If I have more time, I might go through it. I think you'll be able to find these slides online somewhere, so please go through it. The only key thing to maybe add to this is we have a marketplace, so if you develop an app or an analytics package, we're able to take that into suppliers, and suppliers then can purchase that and provide that out to their consumers. So it kind of provides a ready-made scale for the services that you might be developing. The developer portal kind of is like an Apple or Google developer portal where you get account and then you get deep level kind of access keys and you can begin to work with the data. It's all API driven. It looks a little bit scary to people that aren't in software development, but it's quite straightforward if you do this kind of thing for a living. We have language templates, so you can target alerts and notifications in different languages or for different cluster groups. And we publish all of this as RESTful APIs. Again, easy if you understand it. So kind of the uses of data, these are 5 topics that I like to kind of highlight. So data in itself can be used sort of for visual communication, so it's a very good way to monitor something in terms of whether something is over and under a boundary condition. Data is very informative for exploring something, so you may have an idea or hypothesis and you might want to dive down and start to look at what the underlying causes are. So exploration needs a lot of interactivity. Analysis, so this is something maybe you know already and you just want to analyze, or it may be an open-ended analysis question or a model that you might want to create. There are commercial applications of the data, so this might be blockchaining the data in order to monetize it. It could be the metering, which is a way of monetizing the data, of course. And people are starting to do things like trading with the data. So this could be your solar energy or your battery, how much you're consuming or discharging off of a battery. And then of course you've got a kind of the future, and if you look at future build as a topic, it's automation and control. And I think that's where we're headed. You know, lots of automation will be coming in at a lower cost or embedded into systems. I don't think there'll be one platform for control. I think there'll be lots of signals flowing around, working with ecosystem of the consumer or the building management system's choice. If you've seen Jupyter Notebooks, I'm not going to go through this, but it's quite easy to develop quite sophisticated models. This is a neural network which is doing hour-ahead forecasting based on the hours behind. And we can get a pretty good fit of actual to predicted, at least 3 or 4 days out. So this is a really interesting technique, an application of advanced neural network type analysis. And then there's simple sort of visualization tools. So you can kind of see these partitions of data. So just by plotting the data, you can start to see in an exploration mode really interesting next questions to ask. This is a plot that sort of informed us about occupancy and how important it was to look at opening hours and how that might correlate to energy use and waste. And then you've got sort of full-blown applications. So this is a company we work with, Eversmart, who's based in Manchester, who's an energy retailer. And this allows for people on their mobile device to come in real time, anywhere they are in the world, look at their consumption and their real-time power. And they can kind of flip, I'm just going to flip through, they can graph it. And what's interesting with this real-time data is you can get this sort of granular resolution. So this is a typical home's electricity pattern, and you can see those patterns overnight. You can see events happening like cooking, refrigeration, etc. Very easy to see by the naked eye, which means machine learning and things have great opportunities to be informed by this data set. Gas, not so granular, still interesting. On the non-domestic side, we're involved in a project that Richard was alluding to called Non-Domestic. We have 3 applications. They're largely web-based, but they're rolling data up. So this is looking across different venues and sort of merging functions. So if it's a restaurant, there's going to be one type of business process versus retail, which is highlighting loads and putting that domain expertise on top of the data sets to do planning, capital planning, investment, return on investment. And I talked about the kind of smart engine and that, but we'd probably invite you, if you want to know more, please come and find me. We're interested in talking to individuals, companies, suppliers of all shapes and sizes. So happy to enable you to get involved with this smart meter revolution.